Welcome to This Explainer. Today, we're diving into a massive, frankly, mind-blowing technological paradigm shift. The era of manual coding, sitting at a keyboard, typing syntax line by tedious line, is rapidly coming to an end. We're looking at a transition that's fundamentally changing how software is built and what it actually means to be a developer in an AI-driven world.
Okay, let's dive right into this. Just take a look at this realization from Boris Cherny, the head of Claude Code at Anthropic. He says that literally 100% of his code is now written by an AI agent, and he hasn't edited a single line by hand in months. No way, right? But think about that. We're already seeing roughly 4% of all public GitHub commits being AI generated, and for top engineers at the absolute frontier, it's hitting near 100%. They're out there shipping dozens of pull requests a day without ever touching the actual syntax.
So here's our roadmap for today's explainer. First, we'll look at the end of traditional code. Then, the shift from developer to architect. Third, we'll examine the impact on the global market. After that, we'll break down the exact skills you need for this AI era. And finally, we'll wrap up with some actionable tactics to optimize your own productivity. Let's get into it. Starting with Section 1, the end of code. Talk to your tech giants. Places like Spotify and Anthropic are confirming that their absolute best engineers just aren't manually typing code anymore. We're totally moving away from the era of writing explicit rules and transitioning into what Andrej Karpathy famously calls vibe coding. It's wild. Engineers are moving toward managing autonomous systems that write the rules for them, purely based on high-level intent. And get this staggering 200% figure. That represents the massive increase in productivity per engineer recently observed on internal teams over at Anthropic. This completely proves we aren't just dealing with some fancy autocomplete anymore. It's a completely different way of working. You're essentially collaborating with an enthusiastic, extremely well-read junior developer who literally never gets tired. AI is no longer a passive tool. It's a true collaborative agent. Moving on to Section 2, from developer to architect. This is the shift from being a typist to being an orchestrator. Because if the machine is doing all the heavy lifting and typing, the human role fundamentally transforms. And this brilliantly illustrates exactly what's happening. Looking at Nate B. Jones's levels of AI coding, in level 1, you treat the AI like a junior dev, right? Just handing off isolated files. In level 2, you step back into a manager role where the AI actually navigates the codebase and submits pull requests for you to review. But ultimately, you reach the product manager level. At this stage, you simply write specifications, walk away, and come back hours later to evaluate the outcomes. Now, most developers actually hit a ceiling here, because, let's face it, it's psychologically difficult to let go of the code. But human engineers absolutely must step back and let the AI handle the implementation. So let's compare these two worlds. The old role, that was all about writing syntax and coordinating massive human teams through endless stand-ups and Jira boards. But the new role is all about writing incredibly precise specifications and orchestrating AI agents. That traditional coordination layer is essentially collapsing. We're entering an era where the real bottleneck is human articulation. Can you describe the business problem so clearly and precisely that an autonomous machine can solve it without needing to ask a single clarifying question?
Which brings us to Section 3, the impact on the global market and its shifting demands.
The data here paints a pretty stark contrast. On one hand, traditional junior developer postings in the US have absolutely plummeted by 67%, and graduate tech roles in the UK are down 46%. Organizations simply don't need humans for basic syntax generation anymore. But on the flip side, the CEO of LinkedIn noted a massive influx. We're talking over 1.3 million new AI-centric jobs that didn't even exist a year ago. So the market isn't necessarily shrinking overall, it's just completely shifting what it demands from us. So why aren't engineering jobs totally evaporating? Well, it all comes down to the Jevons paradox, a concept echoed by major leaders like NVIDIA's Jensen Huang and Uber CEO Dara Khosrowshahi. Dara actually said, "I'm going to hire more engineers because I want to go faster. There's still lots of unsolved problems." See, because engineers are now exponentially faster, the actual cost of solving problems plummets. Therefore, companies will actually hire more of them to tackle the infinite backlog of human imagination, whether that's in healthcare, science, or logistics. All right, Section 4, skills for the AI era, what it takes to be the AI manager. So, the crucial point is, as basic software creation becomes a total commodity, the key to adapting is agentic engineering. This means working with AI as an active collaborator, one that can use tools, navigate your system, and actually take action in the real world. You really have to treat your AI like a brilliant but raw junior developer.
Sure, it knows every coding framework ever created, but it severely lacks real-world business judgment and context. And that judgment, that is exactly what you provide. So here are the essential human skills that matter more now than ever before. First, systems-level thinking, really understanding how the entire architecture fits together. Then, deep domain expertise, knowing exactly why your specific business has that one weird edge case. Human communication and creativity are huge, too. And finally, generalist knowledge. Specialists who only know one narrow tech stack are becoming way less valuable than generalists who can bridge product, design, and engineering to evaluate the AI's output holistically. Finally, Section 5. Optimizing your productivity with daily tactics. Now that we know where the industry is heading, here's your daily rapid-fire playbook gathered straight from top minds at Anthropic and LinkedIn. First, spend 20 minutes every single day feeding your AI context. Upload your docs, give it your world, basically build it into a second brain. Second, always use the most capable model available. It might seem more expensive up front, but it actually takes far fewer tokens to get the correct answer. Third, utilize plan mode. Literally have the AI write down its logic before it writes a single line of code. And finally, remember the bitter lesson of AI. Don't box the model in. Give it high-level goals and the freedom to solve problems without overly strict micromanaged constraints. Let it do its thing. As the traditional title of software engineer slowly fades into simply builder, I want to leave you with this provocative question. What will you build now that coding is solved? Seriously. You now have the power of an entire engineering team right at your fingertips. The traditional barrier to entry is completely gone. Your newfound superpower is literally limited only by your imagination and your judgment. So get out there and build something incredible.
So picture a software engineer, right?
Yeah.
Like a really high-level one.
Okay, I'm picturing it, lots of typing, multiple monitors, the whole deal.
Right, exactly.
Yeah.
Well, there's this guy, Boris Cherny. He's a software engineer at Anthropic. But the thing is, and this is wild, since late last year, he hasn't typed a single line of code.
Wait, not one?
Not one single line. And here's the crazy part. Every single day, he's shipping like 10 to 30 major pull requests.
Wow.
Yeah. I mean, he is pushing these massive structural changes into the live code base at Anthropic, one of the top AI labs in the world. And he does all of it without touching his keyboard to write actual syntax.
That's just staggering. 30 pull requests a day.
Right.
Because just for context, that kind of productivity is what a senior engineer might historically achieve in like a month, maybe 2 months if it's a complex system.
Exactly. And he's doing it before dinner. It just shows that the person swinging the digital hammer, the traditional coder, as we've known it for the last 50 years, is basically dead. So welcome to today's deep dive.
I'm really excited for this one. Because the fact that the physical mechanism of creating software, the actual typing part, has been completely decoupled from the intellectual process of building software, it's huge.
Oh, totally.
I'd argue it's the most significant shift in knowledge work since the invention of the personal computer itself.
Absolutely. And if you're joining us today, you're probably sitting somewhere, maybe driving to work, trying to make sense of a landscape that is just it's shifting under your feet right now.
Yeah, it really is.
Like maybe you're prepping for a strategy meeting tomorrow, and you're wondering why your company's tech budget is ballooning, but the productivity seems completely flat.
Which is happening everywhere, by the way.
Right. Or maybe you're a developer or a middle manager, and you're just trying to figure out like where your career is going to be in 4 years, because things are moving so fast.
They really are.
So our mission today, we're dissecting a massive stack of recent insights. We're talking mid-2026 data, interviews, geopolitical reports. We've got stuff from leaders at Y Combinator, LinkedIn, Box, NVIDIA, Anthropic.
It's a gold mine of information.
It really is.
Mm-hmm.
And we're going to explore how the role of the knowledge worker is fundamentally transforming. Like we are all becoming orchestrators of artificial intelligence.
Then we're not just going to talk high-level philosophy here, right? We're going to get into the immediate practical playbook for surviving this.
Yes. The actual tactics.
Because there are specific frameworks out there right now for managing virtual employees, optimizing your personal workflows, and dealing with the absolute nightmare that is legacy code.
Oh man, the legacy code stuff we're going to get into is fascinating.
It's so important. And we also have to look at the macro level. The geopolitical ground is just shifting so rapidly. We've got data on the collapse of entry-level hiring in the West, and we need to look really closely at places like China.
Right, how they're dealing with the hardware embargoes.
Exactly. through sheer algorithmic efficiency. It's a lot to cover.
It is. So let's just jump right in. Let's start with that fundamental shift in the daily reality of the software developer. You brought up this idea earlier of decoupling the typing from the thinking.
Yeah, it's the core concept.
And our sources point to this incredible framework. It was coined by Neat B. Jones, and he calls it the 5 levels of AI coding.
I love this framework. It really maps out exactly where the industry is right now and, frankly, where a lot of people are currently trapped.
Okay, so let's break it down for the listener.
Yeah.
Because it's not just a binary, right? Like humans code versus AI codes.
Right. No, it's a spectrum. It's a spectrum of automation. So level 1, this is where the vast majority of the industry woke up maybe a couple of years ago.
Like autocomplete era.
Exactly. The human writes the code, and the AI acts as a hyper-advanced autocomplete tool.
So I start typing a function, and the AI just predicts the rest of the line based on statistical probability.
You're still the one driving the car. The AI is basically just making the steering wheel a little lighter.
It's an incremental speed boost. But then we get to level 2. And this is where the friction really starts, right?
Yeah.
Jones calls this level 2 AI as a junior developer.
Yeah. Level 2 is tricky. At this level, the AI can handle multi-file changes. It navigates the code base. It understands how different modules interact. It can even build entirely new features.
Which sounds amazing.
It does. But the catch, and this is a massive psychological hurdle, the human developer is still reading and reviewing every single line of code that the AI produces.
Wait, hold on. Let me push back on that for a second. If an AI is spitting out hundreds of lines of code, shouldn't a human be reading it?
You'd think so, right?
Yeah. I mean, that sounds less like a psychological hurdle and more like just, basic responsible quality control. Why is reading the code framed as a trap here?
Well, the data says 90% of developers who think they are, like, cutting-edge AI native are actually stuck right here at level 2.
Okay, but why is it a bottleneck?
Because of the cognitive load.
Yeah.
Think about the energy required to comprehend someone else's logic, or in this case, a machine's logic. Oh, I see. It's like reading a dense legal contract versus writing one yourself. When you write the code yourself, you hold the entire architecture in your short-term memory. You know exactly why every variable is named the way it is.
Right. The context is all in your head.
Exactly. But when an AI generates this massive block of code in seconds, and you're just sitting there trying to read it line by line to make sure it's correct,
Yeah.
you're actually slowing the whole process down to the speed of human reading comprehension.
Wow. Okay, yeah, that makes total sense. You're forcing a machine that operates at the speed of compute to wait for a biological organism to read syntax.
It's terrible for efficiency.
Yeah.
And it's actually worse than that because it creates this false sense of control.
How so?
Well, developers have spent decades, right, building their entire professional identity around knowing exactly how the syntax works.
Yeah, being the smartest person in the room about the code.
Right, so letting go of the code is terrifying for them.
Yeah.
So they cling to level 2, they let the AI write it, but they meticulously read it, which just exhausts them and severely caps their output.
All right, Jones points out you literally cannot scale your productivity if you're manually parsing AI-generated code, which forces the leap to level 3.
Level 3 is where it gets real. Developer is manager.
So the relationship completely inverts here, right?
Totally. You are no longer writing code with an AI assistant. The AI is autonomously writing code and then submitting pull requests to you.
So your job changes completely. You just decide whether to approve or reject the request based on the overall behavior of the feature. You don't care about the spelling of the syntax anymore.
You're transitioning from a proofreader to a product manager. You just look at the output. Does the button do what it's supposed to do?
Right. Does the database update? Does it pass security tests?
If yes, you merge it. You really don't care if the AI used a for loop or a while loop. It's like a CEO doesn't care what brand of pen their accountant uses to sign the ledger.
That is such a good way to put it. But I mean, this feels like a massive leap of faith.
It is, and it requires a total redesign of your testing environment. You can only trust the AI at level 3 if your automated testing is basically flawless.
Because if you don't have good automated tests,
Then you have to read the code, which puts you right back at level 2.
trapped reading syntax again.
Yeah.
Okay, let's push into level 4 because this is where it starts getting into science fiction territory. Even though our sources say it's happening right now.
Level 4 is developer as product manager.
So at this stage, you write a high-level specification in English. You tell the system what you want to achieve, and then you literally step away from the keyboard.
You step away, and you come back hours later to evaluate the final outcomes. The AI isn't just writing the code. It's debugging it, running the tests, finding its own errors, rewriting the code, and deploying it to a staging environment.
That's wild. So the human
Yeah.
only interacts at the very beginning, the specification, and the very end.
Exactly. And then, of course, there's level 5, which is fully autonomous AI, building, maintaining, and optimizing systems entirely on its own.
Just running in continuous loops without any human prompting at all.
Right. Now, we are seeing early primitive versions of level 5 in closed laboratory settings today, but level 4 is where the immediate economic disruption is really hitting right now.
I want to use an analogy here just to make sure the mechanics of this transition are crystal clear for the listener.
Go for it.
Because this entire 5-level transition, it feels exactly like the evolution of manufacturing.
Oh, absolutely.
Like level 1 is a carpenter getting a slightly better power drill. It makes them faster, but they're still building the cabinet by hand. Level 2 is like having a robot pre-cut the wood, but the carpenter insists on measuring every single cut with a tape measure before they assemble it.
Which completely defeats the purpose of having the robot in the first place.
Right, but by level 4, you stop touching the wood entirely. You're the person sitting in an air-conditioned control room, programming the robotic arm. You aren't building the car anymore. You're building the factory that builds the car.
That analogy maps perfectly onto Brendan O'Leary's concept of agentic engineering, which our sources highlight as the new baseline for interacting with these models.
Agentic engineering. Break that down for us.
So, O'Leary argues that the fundamental mental block most knowledge workers have is that they still view software as a tool.
Right, like Microsoft Word or Excel.
Exactly.
Mhm.
And a tool is inert. You pick up a hammer, you use it, you put it down. It doesn't do anything on its own.
But agents aren't inert.
Far from it. O'Leary says you have to start treating the AI like an energetic, hyper-enthusiastic, extremely well-read junior developer.
Okay, I love that image.
Right. This virtual employee has memorized literally every piece of documentation on the internet. They never need to sleep, and they have absolutely zero ego.
You can tell them their work is garbage and ask for 10 rewrites.
And they will cheerfully comply instantly.
I mean, that sounds like the perfect employee. Where's the catch?
The catch is that they are entirely devoid of context, and they are often confidently wrong. Yeah.
Like the hallucinations.
Exactly. They do not know your company's business model. They haven't read your internal Slack messages from 3 years ago explaining why a certain database structure was chosen to appease one specific difficult client.
So they'll confidently write code that is technically flawless in a vacuum, but catastrophic for your actual business reality.
Exactly. So if the machine is doing the typing and it operates instantly but lacks that context, the human's value proposition has to completely pivot.
Because historically, a developer's value was all tied to implementation speed, right? How fast can you type out this feature?
Right. But now, if implementation is instantaneous and essentially free, your value is entirely tied to specification quality.
How well can you explain the context?
Precisely. How accurately can you articulate the business problem to an entity that has zero human intuition? We have moved from an economy of implementation to an economy of articulation.
I want to highlight that for the listener. An economy of articulation. The bottleneck isn't how fast we can write the code anymore. The bottleneck is how perfectly we can describe the desired reality.
That's it. That is the new skill.
So let's follow that thread. Because if the developer is no longer a coder, the entire structure of a tech company has to change, doesn't it?
Oh, dramatically.
The sources detail this brutal flattening of the organizational chart. Take the company Cursor, for example.
Yeah, Cursor's the perfect example of this.
We're looking at a company operating at massive revenue levels. I think they passed $500 million in annual recurring revenue with the tiny fraction of the traditional headcount you'd expect.
Because in a traditional software lifecycle, you have all these distinct silos. You have a product manager who talks to the users and writes a document describing what to build.
Right.
Then they hand that to a designer who figures out what the interface should look like. Then they hand that to an engineering team who spends months typing out the logic.
And then QA testing, DevOps for deployment.
Exactly. And every single handoff introduces friction, miscommunication, and massive time delays.
But Cursor just bypasses that entirely.
When you have an AI that can handle the coding, the testing, and the deployment instantaneously, those silos become obsolete. David Heinemeier Hansen DHH describes this as the era of the 3 hats.
The 3 hats.
Yeah. The modern software architect is combining the roles of the product manager, the designer, and the developer into a single brain.
Which makes sense when you think about why we separated those roles in the first place.
Hmm.
We only separated them because coding was so intensely difficult and time-consuming that it required a dedicated specialist.
Right. But if coding becomes as easy as speaking English, the person who understands the user's problem should just build the solution themselves.
Wow. And Mukesh Bansal takes this even further in our sources. He frames this transition as the birth of the AI manager.
Yes, the AI manager. He predicts that in the very near term, every single knowledge worker, not just software engineers, but marketers, financial analysts, HR professionals, you will all transition into a manager of virtual employees.
But managing a machine requires a very different emotional and intellectual toolkit than managing a human.
Right, completely.
Bansal brings up a really sharp point about this. He asks you, the listener, to imagine managing a star human employee who happens to be 5 times faster and significantly smarter than you are.
For most middle managers, that is an incredibly threatening scenario.
Right, it triggers their ego.
And what do managers do when their ego is triggered? They tend to micromanage that person to regain a feeling of control.
But that instinct is fatal when dealing with AI, isn't it?
It is absolutely fatal. If you try to micromanage an AI agent, if you try to dictate exactly how it should write every line of code or format, every single cell in a spreadsheet, you are dragging it down to your level of cognitive throughput.
You're capping its speed.
Exactly. You have to unshackle them. You have to demand high-level outcomes. You don't ask an agent to write a Python script to scrape this website.
What do you ask instead?
You ask it to build a system that continuously monitors our competitors' pricing and alerts me when we are undercut by more than 5%. You ask for the world.
You ask for the outcome, not the steps. I love that. But okay, let's pump the brakes on the utopian vision for a second.
Sure.
Because our sources outline a massive systemic roadblock to this idea of agents just magically building and maintaining everything.
Yeah.
Nate B. Jones refers to this as the dark factory problem.
The dark factory. It is the bane of every enterprise software company right now.
So what exactly is it?
It's the reality of legacy code. AI is absolutely brilliant at greenfield development.
Meaning starting from scratch.
Right. Spinning up a brand new application from scratch where there are no existing rules or dependencies. But you cannot simply unleash an autonomous AI agent onto a 10-year-old monolithic enterprise code base and say, go fix the billing module.
But why not? I mean, if it's read all of Stack Overflow and it knows all the coding languages, shouldn't it be able to figure out a billing module?
You would think so, but no. Because enterprise software is not a clean, logical, mathematical proof. It is a tangled, messy, archaeological dig of human history.
An archaeological dig. Wow.
Yeah. Over a decade, a system accumulates thousands of implicit decisions. There are hotfixes deployed at 3 a.m. during a server outage that were literally never documented.
Right.
There are temporary workarounds that became permanent load-bearing structures. There's a weird convoluted loop in the code that exists solely because one specific enterprise client in 2019 demanded a custom feature, and nobody remembers why.
That is so painfully accurate. I've actually heard engineers say that the code itself is the only true documentation that exists.
That's exactly the phrase Jones uses, the system is the specification. The running code is the only source of truth for what the business actually does.
That's terrifying.
And here is the really terrifying part. The automated tests usually only cover maybe 30% of that reality. The other 70% relies on institutional knowledge.
Just floating around in people's heads.
Exactly. It relies on the memories of a few senior engineers who know where all the bodies are buried.
Okay, so if you tell an AI to optimize the billing module, it looks at the code, it sees a highly inefficient, convoluted loop, and it simply deletes it to make the software run faster.
Yes. And in doing so, it accidentally breaks the payroll system for your largest client in Canada because that convoluted loop was actually a critical tax workaround that nobody bothered to write down in the official documentation.
Oh, man. Because the AI lacks the human context to understand why the bad code exists in the first place.
Exactly. It just sees inefficiency.
So how does the role of the human architect change in the face of the dark factory? We can't just let the AI wreck the legacy systems.
The new job is highly analytical. The human basically has to go into that dark factory, put on a hazmat suit, and do the deeply difficult work of reverse engineering all of that implicit, unwritten tribal lore into explicit, rigorous mathematical specifications.
Wow.
You have to extract the unwritten rules of the business from the brains of the senior staff and turn them into constraints that an AI agent can actually understand and follow.
It's almost like acting as a translator between human corporate trauma and machine logic.
That's exactly what it is.
Which makes me want to pause and consider the human impact of this. Because if you are a traditional middle manager right now, someone whose primary job for the last decade has been coordinating human schedules, tracking dependencies between different engineering teams, moving tickets around on a Jira board.
Yeah.
What is your utility when the execution layer is replaced by agents?
The brutal truth found in the data is that the coordination layer of management is being systematically deleted.
Deleted, not downsized, deleted.
Deleted. When engineers are agents, they don't need sleep. They don't have morale issues. They don't need a 30-minute daily stand-up scrum meeting to coordinate their work. The friction of human collaboration basically vanishes.
And if your entire job was managing that friction, you no longer serve a business purpose.
Right. The value moves entirely away from coordination and concentrates strictly in judgment, deep domain expertise, and the ability to articulate those perfect specifications we talked about earlier.
So the obvious question for anyone listening becomes, how do we actually adapt to this? Like, how do we change our daily workflows to survive this transition?
Well, our sources provide a very specific productivity playbook for optimizing your work right now.
Let's dive into that playbook, because some of this advice is completely counterintuitive. For instance, Boris Cherny at Anthropic, he argues that the best way to maximize productivity in an AI-driven environment is to intentionally underfund your projects.
It goes against every instinct of traditional management, doesn't it?
Yeah. Historically, if a project is important, you throw more human headcount at it.
But Cherny's logic is that human brute force is an enemy of scale. If you give a team plenty of engineers, they will solve problems the old-fashioned way by typing out code and manually fixing bugs.
They rely on muscle memory. They'll do what's comfortable.
Exactly. But if you starve the team of human headcount, yet give them an unlimited budget for AI compute, meaning they can use as much server power and as many AI tokens as they want, and force them into a corner. They literally do not have the human hours to manually type the code. So they're forced to build automated systems. They're forced to design agents that can do the work for them.
Wow. Constraint breeds automation.
Yes. Cherny noted that when they applied this constraint, giving a single engineer massive AI resources instead of giving them a team of juniors, they saw a 200% productivity gain per engineer.
That's incredible.
Yeah.
You shrink the human team, but you open the floodgates on compute power. And that ties perfectly into another massive mental hurdle people face, which Aaron Levy, the CEO of Box, talks about. He advocates strongly for the concept of waste tokens.
Waste tokens, yeah. To understand why this is difficult for people, we really have to explain what a token actually is and how we've been conditioned to think about resources.
Go for it.
So a token is essentially the fundamental unit of data that an AI processes. You can think of it like a syllable of a word or a fragment of an image. Every time you ask an AI a question and every time it generates an answer, it consumes tokens.
Right, and those tokens cost money, because they require physical electricity and server processing in a data center somewhere.
Exactly. So human instinct, especially corporate instinct, is to optimize. We want to use the fewest tokens possible to save money.
We agonize over writing the absolute perfect, concise prompt so the AI gets it right on the very first try.
And Levy argues that this is fundamentally the wrong approach. Human time is astronomically more expensive than machine compute.
Right.
He says you should start trying to be hyper-efficient with your prompts. If you have a complex problem, you shouldn't ask one AI to solve it linearly. You should spin up 10 different AI agents and have them tackle the problem in parallel using 10 completely different approaches.
Knowing full well that 9 of them are going to fail completely.
Yes, you are actively, intentionally wasting 90% of the compute tokens you just purchased. You are burning server time.
Which sounds insane to an accountant.
It does. But here's the magic. While the AI is burning those tokens, running 10 experiments simultaneously, you are out of the room walking your dog or getting coffee.
Yeah.
And when you come back 5 minutes later, one of the 10 paths succeeded. You spent maybe 50 cents on wasted compute, but you saved 3 hours of your own salary.
It's a complete paradigm shift. Optimize for human time, not machine time. Just throw cheap compute at the problem.
Exactly.
And David Andrej, who built a highly regarded course on Codex, echoes this sentiment when he talks about which models to actually use. He says you should always default to the absolute most capable, most expensive model available. For example, he points to models like Opus 4.6.
It's the exact same psychological trap. People look at the pricing tiers and think, oh, I'll use a smaller, cheaper model for this task to save money.
Right.
But Andrej points out a hidden cost. The more capable model might be cheaper per token, but it is vastly more likely to hallucinate, make logical errors, or misunderstand the context.
Which means the human has to step back in. They have to read the bad code, figure out what went wrong, write a correction prompt, and run it all over again.
And suddenly you are spending your valuable human time acting as a babysitter for a cheap AI.
Right. The cheap model ended up costing you way more in the long run.
Exactly. The more capable model, the Opus 4.6 tier, actually ends up using fewer tokens overall and infinitely less human time because it possesses the reasoning capabilities to get the architecture right on the first try. It requires far less hand-holding.
Okay, that's super practical. Now, Andrej also heavily advocates for a specific workflow tactic called plan mode. And I think this is brilliant in its simplicity.
Plan mode is amazing. It addresses a fundamental flaw in how generative AI works. Generative models suffer from path dependency.
Path dependency, what does that mean in this context?
They predict the next token based on the previous tokens. So if the AI writes a bad line of code early in the process, it doesn't usually realize its mistake and start over.
Oh, right.
Instead, it tries to mathematically justify the bad code, building a towering house of cards on top of a flawed foundation.
It doubles down on its own hallucinations.
Exactly. It just keeps digging the hole deeper. To stop this, you inject a rigid instruction into your initial prompt. Do not write any code yet. Output only a structural plan.
Oh, that's smart.
You force the AI to outline the architecture, describe the database schema, and list the edge cases it intends to handle.
And it just stops right there.
It stops. The human reads the blueprint. If the human sees a flaw in the logic, they correct it at the planning stage. Only when the blueprint is flawless do you give the AI permission to actually execute and write the code.
It prevents the machine from rushing down a rabbit hole of confidently wrong implementation.
Exactly. Don't touch the tools until we agree on the blueprint.
That is incredibly practical advice for anyone listening. Now, I want to look at another framework from our sources, this one from Aniket Pandwani. He draws a really sharp distinction between building skills and building web apps, and I think this is crucial for anyone trying to integrate AI into their personal workflow.
Yeah. The tech industry has a massive bias toward building massive applications. When people get access to these AI coding tools, their first instinct is often, I'm going to build a sauce startup.
Right. Everyone wants to be a founder suddenly.
And Pandwani says that is a distraction. You should start by building personal skills.
How does he define a skill in this context?
A skill is simply a set of custom instructions and context designed to automate one specific recurring task in your own life.
Just for yourself.
Right. If you find yourself doing a digital task more than 3 times a week, say, formatting a specific type of financial report, or parsing customer feedback emails into a spreadsheet, you should build an AI skill for it.
Okay.
You don't need a user interface, you don't need a database, you just need a raw script or a saved prompt that handles that exact workflow.
So when do you actually build an app?
You only graduate a skill to a full web application when you hit 2 specific criteria. First, you need persistence over time, meaning the tool needs a database to remember things from yesterday.
Makes sense.
Second, you need a visual interface because you are sharing the tool with non-technical teammates who don't know how to run a terminal script. Until you hit those 2 requirements, keep it as a raw personal skill.
That makes the barrier to entry so much lower. You don't have to be a software founder. You just have to be a person who hates repetitive tasks.
Exactly.
This actually brings up a concept from the sources that I find absolutely fascinating. Latent demand. Boris Cherny talked about this when looking back at the early days of Claude Code at Anthropic.
Yeah, the story of Claude Code is such a great example of this. Claude Code was initially designed as a highly technical command line interface tool. It lived in the terminal.
Right.
It was built by hardcore engineers for hardcore engineers to help navigate complex code bases.
But then they started looking at the telemetry, the user data, and they noticed something bizarre happening. Data scientists, people who don't typically build software architecture, were jumping through massive technical hoops just to install this engineering tool.
Right.
Why? So they could hack it to run complex SQL database queries for them.
And it didn't stop with data scientists. The sources detail how people completely outside the tech sphere were hijacking this tool.
Oh yeah, like what?
One person forced the AI agent to analyze soil data and figure out how to optimize the growth of their backyard tomato plants.
Using a terminal coding tool.
Yeah. Another user pointed the coding agent at a corrupted hard drive and instructed it to write recovery scripts to save their loft wedding photos.
They were taking a tool explicitly designed for typing software syntax and forcing it to interact with the physical world and solve deeply personal problems.
That phenomenon is the pure definition of latent demand. When users actively abuse a product to achieve a goal it wasn't designed for, it is a massive, flashing neon sign pointing to what the market actually wants.
Right. The creators at Anthropic looked at this and had an epiphany. People don't just want an AI that writes code. They want an autonomous agent that can take actions on their computer to solve arbitrary human problems.
And that is the exact takeaway I want you, the listener, to internalize right now. Look at your own daily friction. Look at the things you are naturally trying to hack the AI to do.
Yes. Are you trying to force ChatGPT to organize the chaotic web of your family's Google calendars? Are you trying to get it to cross-reference your personal budget against your credit card statements?
Because that friction, that hack is your next big productivity unlock. Build a custom skill for that exact pain point.
Which serves as the perfect transition into the wider societal impact here. Because these tactics, wasting compute tokens, building personal skills, harnessing latent demand, they are no longer niche tricks for Silicon Valley engineers.
No, not at all. This is rapidly becoming the baseline expectation for every modern worker in the global economy.
So let's examine that ripple effect. Are these skills truly essential for everyone? Nikesh Arora, the CEO of Palo Alto Networks, provided an incredible insight on this, particularly regarding enterprise organizations and cybersecurity.
Yeah, he articulated a fundamental truth about human capital. Historically, a company's total output was strictly capped by the average capability of its workers.
It's the law of averages, right? If you hired 10,000 people, your company's performance is largely a reflection of the median intelligence and capability of that cohort. You're constrained by how fast your average worker can process information.
But Aurora points out that AI destroys that constraint. AI fundamentally raises the baseline of human capability.
How so?
If you take an average, median-performing employee and you arm them with the right AI agent, an agent that has perfect recall of every company policy, instantly analyzes data, and drafts flawless communication, you can elevate that average worker's output to the 95th percentile.
That's wild. It is the democratization of high performance.
Exactly. Suddenly, the person in your customer support department who used to handle 20 tickets a day is now orchestrating an agent that resolves 200 tickets a day with higher customer satisfaction.
Right. Or your mid-level financial analyst is suddenly generating insights that previously required a team of senior quants.
I've heard it described as giving everyone a superhuman exosuit for their brain.
I love that analogy. But that level of elevation comes with massive, unavoidable disruption to the labor market, doesn't it?
Oh, yeah. It has to.
Ryan Roslansky, the CEO of LinkedIn, shared some data that should really be a wake-up call for everyone listening. He stated that the core skills required to perform the average job will change by 70% by the year 2030.
70%. That is a staggering number.
It's massive.
It means that the job title you hold right now might be the same in 4 years, but the daily reality of what you actually do and the tools you use to do it will be virtually unrecognizable.
If you are not actively working to change your job description today, the technology is going to change it for you. And probably not on your terms.
However, the data isn't purely pessimistic. Roslansky also notes that we aren't just systematically destroying jobs, we are creating an entirely new economic paradigm.
Right, there's a creation side to this too.
LinkedIn data showed that 1.3 million new AI-related jobs were created globally that simply didn't exist a year prior. We're seeing titles like data annotator, deployed engineer, and the AI manager we discussed earlier.
And speaking of that AI manager, Roslansky brings up how the nature of leadership changes in this new economy. If you empower 10 individual contributors with highly capable AI agents, those 10 people are going to be building massive projects incredibly fast.
They are generating code, marketing campaigns, and product designs at warp speed.
Right. And because they are moving so fast, they're inevitably going to crash into each other.
Their projects will overlap, their strategies will conflict, and human egos will inevitably flare up. Roslansky argues that the role of the human manager transitions entirely away from being a taskmaster who makes sure people are checking boxes on a spreadsheet.
Because the AI checks the boxes.
Right. The manager becomes a coach and conflict resolver. Your job is to untangle the human friction that arises from hyperproductivity.
You manage the emotions, the strategic alignment, and the interpersonal conflicts, because those are the only things the AI cannot resolve.
And that requires an intense level of psychological adaptability. Mo Gaudat, the former chief business officer at Google X, advises that every professional needs to dedicate a minimum of 1 hour a week purely to learning agility.
Learning agility, that's the key phrase there. The trap many people fall into is waiting for the technology to stabilize.
They say, I'll wait until they release the final, polished version of Microsoft Copilot, and then I'll take a course on how to use it.
But Gaudat points out that a finished version is never coming. The technology is advancing recursively. If you wait for stability, you will fall so far behind the curve that you will never catch up.
You have to build the mental muscle of continuously learning and discarding new, unfinished tools.
And while you're constantly adapting to the shifting digital tools, you must simultaneously double down on the attributes that the AI cannot replicate.
Right. The sources outline these as the 5 C's.
The 5 C's, what are they?
Creativity, courage, communication, critical thinking, and collaboration. The deeply, fundamentally human skills.
Because as the machines commoditize execution, your human judgment becomes your only valuable product.
Exactly.
And it is absolutely crucial that we dig deeply into why human judgment is so important, because delegating judgment to an artificial intelligence has a very dark, very dangerous side.
It does.
To understand this, we need to look closely at a report provided in our sources from an outlet called Inside China Business.
Now, before we unpack this specific event, we need to state clearly for the listener, the following is a direct, impartial report of the claims made in the source material provided to us. We are not endorsing these viewpoints, nor are we taking any political stance, left or right. We are simply conveying the information as it was presented to illustrate a critical life-or-death lesson about the psychology of human-AI interaction.
Thank you for stating that. So according to the source, the United States military had been utilizing an AI system called Maven, which was developed by Palantir.
Maven is an intelligence integration system. Its purpose is to handle the massive information overload of modern warfare by ingesting satellite imagery, drone video feeds, and radar data, and then rapidly using AI to classify and identify potential military targets.
The source claims that on the first day of a conflict in Iran, the Maven system generated hundreds of potential targets for the military to strike.
However, the system allegedly suffered from a severe data lag. It identified a specific compound as a high-value military target based on satellite imagery that was actually 10 years old.
Right. And in the intervening decade, that specific compound had been repurposed. It was no longer a military installation. It had been converted into a girls' school, complete with newly constructed playgrounds that were visible from the air.
According to the report, the AI completely failed to recognize this physical change. It either lacked the updated training data, or it hallucinated the current status of the target based on its historical weights.
And because the human operators relied on the AI's targeting package, an AI which was reportedly operating with a lower accuracy rate that experienced human analysts, it led to a tragic, catastrophic missile strike on the school.
Again, we are reporting the claims from this specific source strictly to highlight a vital psychological concept that applies to anyone using AI, whether in warfare, healthcare, or corporate finance.
And that concept is automation bias.
Automation bias. It's the documented psychological tendency for humans to blindly trust the output of an automated, computerized system, even when there is clear, contradictory evidence available in the real world.
It's the phenomenon where someone drives their car into a lake because the GPS told them to turn right, and they trusted the glowing screen more than their own eyes looking at the water.
Exactly, but when you apply that bias to systems that control military targets or financial markets, the results are devastating.
The UI of these systems plays a huge role, doesn't it?
A massive role. An AI doesn't present a target and say, I'm 60% sure this is a military base, but you should probably double check. It presents a clean, glowing red box on a highly polished interface.
It makes statistical probabilities look like absolute objective certainties.
And humans are neurologically wired to defer to that kind of confident authority.
The takeaway here is profound. AI entirely lacks human context. It lacks a foundational understanding of ethics. And most importantly, it lacks a physical world grounding in truth.
An AI does not know what a school is. It doesn't know what a child is. It only knows pixel patterns, matrix multiplications, and statistical probabilities.
And this leads to the ultimate rule of the new economy. When you delegate authority to an autonomous agent, you can make it pull the trigger, or execute the stock trade, or send the company-wide email. But you absolutely cannot delegate responsibility.
Human oversight is non-negotiable. Whether you are an executive launching a marketing campaign that could permanently ruin your brand's reputation, or a developer deploying software that handles the life savings of thousands of people, you have to be the human backstop.
You have to look at the pristine, confident output of the AI and have the courage to say, wait, does this actually make sense in the physical world?
Because when things go wrong, and they will go wrong, you cannot stand in front of a judge or your shareholders or the public and blame the AI. The moral and legal responsibility rests entirely on the human who designed the system and the human who approved the output.
That is a heavy, essential lesson. And it leads us directly into the final massive shift detailed in our sources: the global job market and international AI models.
Because the choices we make about how we trust AI and who physically controls the infrastructure that runs it are violently reshaping the geopolitical landscape.
Let's start by looking at the talent reckoning happening right now in the West.
The data on global hiring trends paints a very stark picture of what happens when corporations succumb to a form of economic automation bias. We are seeing a massive plunge in job postings for junior developers.
According to the sources, which include data from Harvard, entry-level tech roles have dropped by 57% in the United States and 46% in the United Kingdom within a staggeringly short time frame.
Why is that happening so fast? Because executives are looking at their quarterly bottom lines. They are looking at AI models that can produce level 2 boilerplate code at a good enough level of quality.
Right. And they are making the calculated decision that they would rather pay a fraction of a cent for cheap AI compute than pay an $80,000 salary to hire and train a human junior developer.
The entry-level work, the tedious bug fixing, the writing of basic test scripts is being entirely automated away.
And this creates a terrifying systemic vulnerability for the entire industry, doesn't it?
It really does. The software industry has always functioned like an apprenticeship. Junior developers write bad code, senior developers review it, and over 5 years, the junior developer builds the intuition required to become a senior architect.
If corporations stop hiring juniors today, how do you ever get senior developers 5 years from now?
You don't. You sever the training ladder entirely.
The senior developers we have right now are highly effective because they are using AI to patch the gaps in their own workflows, combining the machine speed with their own deep, hard-won human intuition.
But the models themselves are establishing a new global baseline of what is considered adequate output. And adequate is no longer a viable career position for a human being in the West.
So the entry-level jobs in the US and Europe are vanishing. But Imad Mostak, the founder of Stability AI, points out that this automation is sparking a massive global shift, particularly concerning India's economy.
He argues that AI translation and English proficiency models are going to hypercharge India's corporate sector in ways we haven't fully anticipated.
Historically, India has been a global powerhouse for business process outsourcing and IT services. But there were always inherent frictions: language barriers, cultural nuances in communication, and the pure logistical lag of coordinating across time zones.
Mostak notes that as AI perfects real-time English proficiency, cultural translation, and instantaneous code generation, those historical frictions disappear.
The Indian outsourcing companies will suddenly be able to compete on a completely different playing field.
Exactly. They will transition from providing raw human labor hours to providing what Mostak calls service as software.
Service as software.
They will offer fully integrated, hyper-efficient AI agents managed by Indian domain experts, delivering massive corporate output at a fraction of the traditional cost. It's an explosion of global productivity that bypasses the traditional Western hiring bottlenecks.
But the real heavyweight geopolitical fight detailed in our sources is the AI infrastructure race between the United States and China. And again, we are analyzing this impartially, strictly through the lens of the economic and technological data provided to us.
To understand the stakes of this race, we have to look at NVIDIA CEO Jensen Huang's concept of the 5-layer AI stack.
Huang provides a brilliant mental model for how the entire AI industry is physically constructed. He breaks it down into a foundation of 5 distinct layers.
The absolute bottom layer, the bedrock of everything, is energy. You need massive, uninterrupted amounts of electricity.
Sitting on top of that energy layer are the chips, the physical silicon processors like NVIDIA's GPUs.
Above the chips are the data centers, the massive physical warehouses that house and cool the computers.
Then on top of that hardware, you have the models themselves, the algorithms like ChatGPT, Claude, or Gemini.
And finally, sitting at the very top of the stack is the apps layer, the actual software interfaces that consumers and businesses interact with.
The sources, specifically the Inside China Business Report, outline a severe and growing bottleneck for the United States at the very bottom of that stack: energy.
U.S. data centers required to train and run these frontier AI models demand a staggering amount of power. We are talking about the energy equivalent of adding an entire country the size of Canada to the U.S. electrical grid.
And that physical energy infrastructure simply isn't being built fast enough in the United States to keep pace with the demand. The grid is constrained.
At the same time, the capital expenditures, the CapEx by the big Western tech companies, are soaring into the hundreds of billions of dollars. They are buying every NVIDIA chip they can get their hands on and building massive data centers.
But here is the economic trap outlined in the data. The tech giants are taking on massive infrastructure debt to build this hardware, but the end users are not currently paying enough for AI subscriptions to cover those costs.
$20 a month subscription to ChatGPT does not mathematically cover the billions spent on the data center required to run it. The economic math of the U.S. model, according to this source, is becoming highly precarious.
Now contrast that precarious, hardware-heavy approach with the China model described in the source material. First, look at the bottom layer. China has a massive abundance of energy. They generate more power than the U.S., the European Union, and India combined.
Furthermore, they operate on a state policy of overbuilding infrastructure ahead of demand, rather than waiting for market signals.
So they have the energy layer and the data center layer secured. They also have a strict state policy to completely delete and replace all U.S.-made software in their state-owned enterprises by 2027, creating a massive captive market for their own apps layer.
But what about the chips layer? This is where the story gets deeply fascinating. The United States government placed heavy embargoes on exporting top-tier NVIDIA chips to China.
The prevailing assumption in Silicon Valley was that without access to the absolute best hardware, China simply couldn't train the best AI models. We assumed hardware dominance equaled AI dominance.
But constraint breeds innovation. And this is exactly where the DeepSeek disruption comes into play. Because Chinese researchers lacked access to the brute force computing power of thousands of top-tier NVIDIA chips, they couldn't just throw raw hardware at the problem the way American labs do.
They are forced into a corner.
Yeah.
They had to innovate at the fundamental algorithmic level.
To explain how they did this, we need to understand the difference between a dense model and a sparse model. Western models traditionally relied on dense architecture. Imagine a dense model as a massive encyclopedia.
Okay.
Every time you ask it a question, the computer essentially has to read the entire encyclopedia cover to cover to generate the answer. That requires massive amounts of electrical power and computing time.
Which requires massive data centers and top-tier chips.
Right. But the Chinese researchers developing the DeepSeek model had to redesign the neural network architecture itself to be hyper-efficient. They utilize what is known as a mixture of experts, or a sparse architecture.
Think of this not as an encyclopedia, but as a vast university with thousands of specialized professors.
When you ask a question about physics, the system doesn't wake up the history professor or the literature professor. It only routes the computing power to the specific subnetwork, the expert, that handles physics.
So it only uses a tiny fraction of the neural network for any given prompt, which drastically reduces the computing power required.
Exactly. The result of this algorithmic efficiency was the DeepSeek model. It runs perfectly on older, cheaper Huawei chips that aren't subject to the embargo.
And because of the sparse architecture, it cost a mere fraction of the price to train. We are talking about roughly $6 million to train a frontier-level model, compared to the hundreds of millions, or even billions, it costs Western labs to train their dense models.
And to make matters infinitely more disruptive for the U.S. industry, the creators of DeepSeek made it open source. Anyone in the world can download it for free.
It completely upended the foundational economic assumption of Silicon Valley. If you don't actually need a billion-dollar supercomputer to train a world-class AI, then the massive CapEx spending by U.S. tech giants suddenly stops looking like an impenetrable moat and starts looking like a massive, bloated vulnerability.
If we pull back and look at the macro implications of this, the sources suggest that the entire era of geographic labor arbitrage is coming to a violent end.
This is a crucial concept. For the last 40 years, the global economy was built on geographic labor arbitrage. That means finding human workers in other countries who could perform the same physical or cognitive task for less money.
Manufacturing moved from Detroit to Shenzhen. IT support and software testing moved from Silicon Valley to Bangalore. The defining metric of global trade was the cost of a human hour.
But AI fundamentally destroys that model. An autonomous AI agent doesn't have a cost of living. It costs the exact same amount of electricity to run a server, whether that server is physically sitting in San Francisco, Mumbai, or Beijing. You can no longer compete by finding cheaper humans.
So what replaces labor arbitrage? The new global economic race is defined by compute arbitrage.
Compute arbitrage.
The victor in the 21st century economy will be the nation that has the cheapest, most abundant energy and the most efficient algorithmic architecture to run autonomous agents at scale.
If China has virtually free, abundant energy at the bottom of the stack and hyper-efficient open-source models like DeepSeek at the top of the stack, they hold a massive structural advantage in the foundational layers of this new global economy.
That is a tectonic shift in how we understand global power.
We have covered a truly staggering amount of ground today. Let's pull all of these threads together for the listener to make sure the complete picture is clear. We started by looking at the death of typing. The old artisanal role of the software developer manually writing out syntax is vanishing.
It is being replaced by the AI manager, an orchestrator who directs autonomous agents across 5 distinct levels of capability.
We learned that in this new paradigm, the bottleneck isn't writing the code, it's writing perfect specifications. The human value lies in navigating the dark factory of legacy enterprise systems, reverse engineering unwritten tribal knowledge into explicit constraints that a machine can follow.
We saw how the coordination layers of middle management are disappearing, placing an absolute premium on deep domain expertise and the articulation of complex business logic.
We looked at the practical playbook for surviving this transition, underfunding your projects to force automation, aggressively wasting cheap compute tokens to run parallel experiments, and listening to the latent demand of what the AI naturally wants to do in your daily life.
We discussed the absolute non-negotiable necessity of human oversight, highlighted by the tragic failures of systems like Maven, reminding us that while we can automate execution, we can never delegate our moral and legal responsibility to a machine.
And finally, we saw how these technological forces are reshaping the globe. They are wiping out junior-level training jobs, empowering new regions through frictionless language translation, and shifting the entire geopolitical battleground from human labor arbitrage to compute arbitrage, where energy abundance and algorithmic efficiency reign supreme.
So after all of that, what does this actually mean for us? Where do we, as humans, go from here?
I want to leave you with a final, deeply provocative thought drawn from the work of Andrej Karpathy, one of the most respected minds in artificial intelligence. We've spent this entire hour talking about how humans can manage AI to build better software, or how humans can optimize AI to run companies, but Karpathy is looking past that paradigm entirely. He is focused on something called auto-research and recursive self-improvement.
Recursive self-improvement, meaning the AI is instructed to improve its own capabilities.
Exactly. Imagine taking a highly capable AI model and giving it a single overarching objective metric. Optimize your own underlying neural network architecture to run faster and smarter. You don't ask it to build a web app for a client. You ask it to build a fundamentally better version of itself, and then you just leave it running in a closed loop, completely unattended by humans for weeks at a time.
It generates a new architecture, tests it, finds a slight improvement, implements it, and starts the loop over again millions of times.
Yes. Karpathy noted that he was shocked by how effective even very simple, primitive versions of this automated research loop were. If an AI becomes its own best developer and its own best AI researcher, relentlessly optimizing its core code at the speed of compute without any human intervention or specification, where does human intuition actually fit into the feedback loop of tomorrow?
That is the ultimate question. When the machine is capable of building a better machine, what is the role of the biological human? We are stepping into an era where the most valuable thing you can bring to the table is not your ability to execute a task. It's not your ability to type syntax. It is your ability to envision a future, to define the ethical boundaries of that future, and to apply profound human wisdom to the chaotic, accelerating speed of the machines.
The transition from the old world to this new reality is going to be painful for a lot of people who cling to the past, but the potential for those who adapt is truly boundless.
So our advice to you: Start experimenting today. Find those repetitive, frustrating tasks in your daily life and build a custom AI skill to solve them. Lean into the discomfort of managing these strained, energetic, confidently wrong digital agents.
Because the typing is dead, the keyboard is going silent. It is time to stop typing and start orchestrating. Thank you for joining us on this deep dive. We'll catch you next time.
Benvenuti a questo approfondimento, ragazzi. L'era dell'ingegnere del software tradizionale è ufficialmente finita. Pensate un po', in Anthropic i migliori ingegneri fanno scrivere il 100% del codice all'IA. Pazzesco, no? E i dati di Spotify lo confermano. Scrivere codice a mano è una pratica praticamente morta oggi. Come dice Jensen Huang di NVIDIA, programmare era solo digitazione. Il vero obiettivo? Risolvere problemi complessi.
Da qui nasce un'identità professionale del tutto nuova. Vi presento il costruttore.
Mentre i programmatori si perdevano nella sintassi, i costruttori si concentrano sui risultati, orchestrando l'IA.
Lo conferma l'ex CEO di LinkedIn, che ora assume questi costruttori basandosi esclusivamente su ciò che creano. Ma sapete qual è la vera rivoluzione? Il modo in cui trasforma i ruoli non tecnici.
Product manager e designer non devono più aspettare gli ingegneri, ora l'IA dà loro veri superpoteri tecnici.
Questa spinta verso ruoli meno tecnici sta generando in Anthropic un balzo di produttività del 200%. Per capirci, gli esperti paragonano questo impatto enorme direttamente all'invenzione della stampa a caratteri mobili. Proprio come la stampa ha democratizzato la lettura, l'IA sta democratizzando la creazione di software per tutti. Attenzione però, il vostro agente IA è come uno sviluppatore junior velocissimo, super entusiasta, ma cieco. Gli manca totalmente il giudizio del mondo reale, il contesto aziendale e soprattutto l'empatia per i clienti. Quindi, come funziona ora? Voi scrivete le specifiche, l'IA fa il codice e voi valutate i risultati. Il vero ostacolo oggi non è quanto veloci digitate, ma quanto bene scrivete queste specifiche.
L'abilità fondamentale sta passando in fretta dal coordinare un team al saper dare istruzioni precise alle macchine.
Per avere successo, vi serviranno pensiero sistemico, empatia profonda per il cliente e un rigoroso giudizio umano. Di conseguenza, mentre l'IA gestisce l'ingegneria, l'organigramma si appiattisce e il management tradizionale sparisce. Vi lascio con una domanda cruciale. Siete pronti a smettere di programmare e iniziare a costruire davvero?